Alright, so that is all the second derivative test is about. If you have the critical point 0, 0, if everything is about powers of x and powers of y. In general, you have to work with those x minus x0, y minus y0. So what I suggest is that you well, the important thing is you never, don't even think about taking the second degree approximation and expanding those squares. If you look at the Taylor approximation at that point, then it must be in terms of powers of those differences. You never expand, because otherwise it will be totally different Taylor series, and it will not tell you about this critical point. So it must be about powers of those differences. So what I suggest is you denote, for technical reasons, you denote x minus x0 by your favorite letter. You may choose your own. What about sh or sh? Or you like sh? You probably don't have sh in the list of your favorite letters, right? So I'll denote it by alpha. And y minus y0 was denoted by beta. And then this will simplify notation for you. It will make it easier to work through that completion of squares. Because in this notation, your function will look like, well, the expression on the right, not the function, but expression will look like a constant plus a number times alpha squared plus number times beta squared plus number times alpha beta. So you rewrite as constant plus a coefficient, some c1 times alpha squared plus c2 times alpha times beta plus c3 times beta squared. And once you rewrite your Taylor approximation in that form, it is already something like that. And you proceed with completion of squares for those alpha and beta. All right? So, any questions? Before I ask you a tough question. What to do if the function is alpha times beta minus y squared? What's in the plus y squared? So imagine you do the second degree Taylor approximation. Oh, sorry, y. Should not be y, it's beta. Alpha beta plus beta squared. If that's what you see, how do you decide? And what do you do? You see, it's not obviously saddle, because for the obvious saddle you need alpha times beta only, no squares at all. And you have square. So you cannot immediately decide. But how do you proceed? You can pull out the beta, yes. And then what? But you see, now you want to reduce it to squares. All you can do and all you have to do is to make it sum of squares or difference of squares. And pulling out beta doesn't help to create squares. How can you create a square? Can you complete a square? There is no alpha squared. That's a problem, isn't it?
It has something with the gas. I don't have a set.
Can you still complete the square? Why don't you try completing beta squared? Can't you complete a square with beta? minus alpha over 2 squared. And that's it, right? You see a difference of squares. And that's the saddle. So if you don't see one of the squares, you just proceed with completion of squares with respect to the other one. So that's not a problem. The only case when you cannot start completing squares is when you only have alpha beta. No alpha squared, no beta squared. But then it's a saddle immediately. Now, you see, the complication here is that you have to decide how to complete the square. So this is the point where you really have to know this procedure of completing square. Because in the past, I mean, you can solve the quadratic equation without completing square, just by memorizing formula. Right? At this stage, you really have to complete the square, and Wolfram alpha cannot do it for you. I mean, if you try, it may give you the complete square form, or it may not. And the reason is that for completion of squares, one has to choose a variable and complete the square with respect to that variable. And Wolfram alpha doesn't know what you want. Right? It won't be able, it won't know which variable to choose. So it may succeed, it may fail. Any questions? No questions?